Well, hello and welcome to another DevNation. I'm super excited to be here today because we have Emmanuel Bernard, who's actually one of our resident experts in all things Hibernate, but he's also a key contributing member to Quarkus, meaning he's one of the guys who invented this technology. So he can really take us deep down this path in the next 30 minutes we have together. And I've known Emmanuel now for probably about 13 solid years. So he and I go way back. I'm not saying that we actually like each other, but we tolerate each other pretty well. So it is a great pleasure. I'd like to introduce Emmanuel Bernard. He's going to take us into this presentation right now. Do make sure you throw your questions into the chat tab and feel free to help everyone understand. They have to refresh their browser to hear things and see things. Thank you so much. Let's go, Emmanuel.
Thank you. Yeah, I love you, Burr. Don't worry. Thank you, everyone, for being here. Really happy to go and explain what we're going to talk about today, which is how does Quarkus handle persistence and how can you take Hibernate to the next level? Let me share my screen right there. So let's do a little bit of slides, and then I'll actually go most of the time going to do a demo to show you everything in action. So what is Quarkus, first of all, very quickly, because some of you might have already seen the previous DevNation. So it's literally a stack to write Java applications, nothing more, nothing less. But we're going to see how it makes it in a very unique way. While you can write just about any Java app and so on, we do focus on a few things. First of all, we're cloud native in the sense that we expect, we make it very natural to work in a very let's say, agile deployment platform. And by that, I'm thinking about a container platform like Kubernetes and so on, where you can really deploy stuff on the fly, scale to maximum levels very quickly, add new services and so on. And we do focus on microservices in the sense that we really work hard to make the startup time very small and the memory usage very small. When you go from one monolith to 20 microservices, then whatever overhead you had in memory starts to pile up, and that's what we wanted to address. And finally, serverless. I did mention startup time, but serverless is keen into low memory usage, but also startup time has to be really fast. And that's what we worked on, make Java really shine into those three pillar environments. So Quarkus has 4 benefits. The one I will really focus today is benefit number 1, which is the developer joy, and I will show that with a persistence angle. We'll see. We reuse a lot of existing technology that you know and use already, whether they are standards or de facto standards, but we make them easier to use by unifying a lot of the configuration. We've got an awesome development mode, which makes the feedback loop from coding to testing back to coding, very, very fast. And essentially, we try to list all of the common usage and patterns and simplify them. That's what Panache is about, and that we're going to talk about today. The benefit number 2 is the memory improvement and the startup time improvement. So I won't go into too much detail, but this is a real-life REST plus JPA application. If you take the stacks that are existing out there, you will use probably about 218 resident set size memory, not just the heap size, the resident set size, which is the one that matters because that's when something like Kubernetes will start to kill your process when you go over. Quarkus is about half that usage total when you use it. And if you go for native image compilation, which we will discuss very quickly a bit, you can get another 8x, factor. Startup time is really impressive as well. Existing stack go from 9 seconds and Quarkus to 2.5. And when you use the native image compilation, we're talking about tens of milliseconds. For Java, that's unheard of. Benefit number 3 is right now, if you have to do a reactive application, that's literally a different stack, different components that your classical imperative model. We are unifying that with Quarkus. I think there is a DevNation setup for that very specific subject, so I won't dive into that subject. And also, Quarkus is made of all of the technologies you're already using, whether it be Hibernate, Vertex, REST-easy, and so on and so on. So it's really based on the things you already know, which means you already have 5 years of experience with Quarkus, which always a nice benefit. And that's enough talking. Let's go into the demo. So I cheated a bit, and I prepared the I literally created the default project with Quarkus. We have a way to do that with a Maven plugin. Then I copied the front end, resources like JavaScripts and so on, just because it's not the area we're going to focus on today. And I opened my IDE, and in this case, this is IntelliJ. And what we have is essentially REST-easy resources that will return when you call hello, and that's the default one. So let's get it started. Nothing fancy here, except I will use the Quarkus dev mod, which is the live reload mod, which is the way you tend to write Quarkus application. You start this mode and you keep starting on this one. So you see that the debugging is enabled, so you can activate the debugger right on the fly. And here the install feature are CDI and REST-easy for my application. And if I go and literally ask my application, I've got a landing page that explains to me what to do with Quarkus. And if I go for the hello resource, then I see hello, nothing fancy here. So let's go and do a DevNation. Let's say hello DevNation. I go back, I refresh, and I see the change right away, right? Hello DevNation live. I go and refresh. Oops, got an error. Yes, he just told me that I probably messed up my Java syntax. Yes, I actually deleted the comma here. I refresh, and I'm back here. I didn't repackage, recompile, did anything on that. I went from my IDE to my browser and back to my IDE, and everything was working. How does it work? Essentially, you can see it in the source. Quarkus actually, when you do a browser query, it will look if any file has changed in your application. If there is one file, whether it be a Java file or a resource, then it will it will compile the file, stop the Quarkus application, restart the whole Quarkus application, and answer you. And in this case, it's in under 300 milliseconds, which means by the time you flip to the browser, you're already live and ready. So that's very, very powerful. And we apply the same kind of logic for tests. So if I run this test, it will fail because, as you see, I'm expecting hello here. So let me prepare the correction for the test. And what the test does, thanks to the add Quarkus test, is literally start the full Quarkus application, and then you run the test, embedding the test, and then you can run whatever test you want to run in the application. Because it's so fast, it makes tests very fast. You don't have to wait for seconds and seconds to, I guess I started it again by accident. Okay, but that's nice, but it's a very simple application. What I want to actually do, actually let me restart it. What I want to actually do is write a to-do application, which I do have the front end, but I have no back end. So if I do something, then actually nothing happens because there is no route, no REST endpoint that actually do something. So what I need to do is add Hibernate and a few other dependencies, right? I can just delete my POM file, but in this case, I want to explore a bit. So I can use Quarkus.live extensions. Not live, sorry, list extensions, which will list me all of the Quarkus. What am I missing here? I'm lost here. Give me 1 second. Well, it's not really a problem. So list extension will list the list of extensions you can also see in the on the website. So if you go to Quarkus.io/extensions, you will see we've got lots and lots of extensions here that are essentially your dependencies. So let me speed by a little bit here and by adding the extensions that we're interested in today. So as you can see, there is the JDBC Postgres driver, there is Hibernate ORM with Panache, we're going to mention that a bit later, and Hibernate Validator, and the JSON binding for Rest Easy. And when I do this operation, then it's just does nothing very fancy. It's literally just update your POM. If you see IntelliJ just says, hey, your POM has changed. Do you want to onboard that? And that's what we're seeing. We're seeing Postgres, Panache, and Hibernate Validator. Okay, the second step is probably to set up a database. So if you're familiar with Hibernate, you have to go and set up a persistence.xml. If you're not so familiar with Hibernate, you might not know exactly all of that incantation and the essentially choreography you have to do to set up that. So Quarkus simplifies that by going into a single configuration file. Of course, you can use persistence.xml if you really need to or want to, because you want to stay in this model. But here we really try to simplify it. Just the fact that you have data sources, URL driver, and so on is enough, and an entity class somewhere in your application is enough for Hibernate to start properly. And here I've added a couple of extra Hibernate-specific properties. Okay, we're ready to go. Let's define a to-do resource. That to-do resource is going to be the backend of my application. So it's going to be a REST easy resource, defining as answering on API, and I will consume. Sorry, oops. I'll consume, JSON structures and probably produce also JSON structures. And the next step is to get the list of all of the resources, all of the to-do in my application. So it's a get, and I do a list of to-do and all. Think about the flow of my coding, right? I just write what I want, and then I'm thinking, okay, I need this to-do, which is my JSON file. So I need to create it. That's the Java representation of my JSON file. So I go and create this file. And because it's a relatively simple application, that JSON file will also be my entity. So I'll mark it as add entity. And I can use regular Hibernate, and then in my resource file here, just do an add inject of the entity manager and use it the normal way you use Hibernate. But here I want to use Hibernate with Panache, and specifically the active record way to do that. So active record is essentially a way to merge the entity code and the repository code, or the DAO code, into one class. So let's do that. I do extend add Panache entity, which means I inherit a few utility methods, which we will see, and also the ID, right, by default, if I want to. So here I can focus on my business logic and say, well, a to-do as a title. It's a regular entity, so I can make it, I can put the JPA annotations. I can use the Hibernate validator annotations, or the bin validation annotation rather. I can add more properties. I'll say that a to-do can be completed or not completed, and I say maybe I want an order of the to-dos to make priorities, right? So I'll put it here. And because order is a reserved keyword, I'll name the column something else. Ordering. There we go. Okay, I've used public fields, which might be a bit strange to you, but it's much simpler not to have to generate the getters and the setters and maintain that. So in your to-do resource, you will just use the public fields. If you say, oh, but I want this abstraction, I want the encapsulation, you can definitely create, you can definitely create your getter and setter. And if they are present, well, they will be used. So when you do to-do resource, when you do to-do.url using the public field, then the get URL will be actually wired in your access. And the reason is that Quarkus does a lot of things at build times, which means it can do bytecode enhancement and transform the code to really be associated. So you can use the getters to abstract. Maybe you want to do a to lowercase or something like that, right? So that's business meaning. Otherwise, just keep the public field. That's going to be a bit more efficient for you. And I mean, as code, right? The way the code shows, not so much in actual performance efficiency. All right, so we've got the to-do entity, and when I say I merge the entity and the DAO in one thing, that's what I mean. I can return. I access my DAO, which also is my entity, and then I've got a list of interesting features, interesting operations here, like list all, which is what I want. But I probably want to order them, so I'll also say that I want to order them by the order field. And I can go back to my application, refresh, and I still see nothing, which is okay. I forgot that I didn't set up any fixture to add data to my database. So I'll again cheat a little bit to speed dial that. For people not familiar with Hibernate, you can create an import.xml.sql file. There you go. And I'm just inserting that, going back to the browser, refresh. So not only Java files are refreshed, but also resources, which is really great. It's a bit too small. There you go. And I've got my application. It's read-only right now. If I say do something, it still does nothing. So let's go and write down this second part. So that would be post, and it's going to return a JSON response, and that's going to create my to-do. And that is the JSON file, the JSON stream that I'm receiving being transformed into a Java file. Okay. Well, that's a creation, so I want it to be transactional. I didn't show you, but if you go there, you will see that we have started with a lot of things like the connection pool, CDI, Hibernate ORM, Hibernate Validator, Narayana, which is our full transaction stack. So we can start the full transaction and still be extremely fast. And also, I'll use bin validation. So that normally in this method, that's where you will want to decide to, okay, I want to validate the input to make sure somebody is not trying to pawn my websites. But let's assume all of that has been written down as Hibernate validator rules. What do I need to do here? Just actually persist this object. So I can do to do, persist. That's all. You see how it flows very nicely from your code. And then I just need to return the response I have created. So I'll return the creation and probably passing back the to-do that has been created and okay. And if I go back, I refresh. Actually, I didn't have to refresh. I can say do something, and now I see that do something has been created. And if I refresh, it's still in the database. However, if I change the state, the update operation, then it's lost because update has not been implemented. So let me implement it. Again, it's very much the same logic, so I'll just copy paste something a bit quickly. Take the code, go back here, and the update is implemented as a patch operation in REST. Then I can get going, refresh, and oops, compilation error. Yes, never trust a code that you copy from somewhere, especially Stack Overflow. So please read it below. But here we saw that there was a problem. Go back, we refresh, and now I can mark the operation as changed, and it's working. The other operation, a bit more complex, that I want to show you is the clear completed. So clear completed is supposed to delete from my database the completed operations. Let's go and implement it. It's going to be a delete operation. Again, it's going to be transactional, so I'm going to set that up. And I'll return a response. And I'll ask to say delete completed. And here, again, I'll use my DAO, which is also my active record pattern, and say delete completed. So here, I don't use a default method. I just want my custom method in the DAO, okay? And from there, I can just say return, I think it's a response, no body, no content rather, and I'm doing it. Okay. Then I go back to my here in my flow. So I've written the flow of my method, and then I can go and fix the the red errors. And here I want to just create the method delete completed, and I navigate to my DAO, which is also my entity, which is very convenient. And then I decide to write the delete operation. So I could say load all the entity and delete them, but here I will just use a delete query, which is something that is supported by JPA, by Hibernate. And here I say delete completed, true. And that sounds scary. What is this language? It's actually HQL, it's JPQL, except we infer a lot of the context. We know we are on the to-do, so select to-do from to-do where it's inferred. You can actually write it down here. You can say delete to-do and so on. But here we infer that you know everything, the from, etc. is inferred up to the where clause. And then you can define the clause. And you could say completed equals something. But here, because equals something is only, there is a single parameter, it's the first parameter, we just ignore this one and you just write completed. So it's plain HQL, except it's very contextualized. Let me show you another one that I love. Let's say we want to write the search engine for that to-do app. So I want to return to-dos. Yes, it's a Java utilist. And that's my search engine. And let's say my search engine receives Word. We want to do pagination, right? You're a busy person, so you probably have lots of to-dos to do. So page here is a Panache type that lets you handle the pagination logic. So let me import it. And from there, just page, just so you know, you can create it. I want a page of 25 elements, so 25 by 25. And I want maybe the second page, so that's the index, third page, index number 3, and so on and so on. And from there, I can write the query. So my query is a bit more complex because I want to say, I want the word to be like the word that I'm receiving, and completed probably should be false, right? So from there, I can say pass the first parameter as word, and oops, completed false, question mark number 2. And here, probably I want the to-dos that are not completed in my search engine. That's probably the one that makes more sense. Then I apply the page, and I return the list. And that's it. I've made a search engine. And you can see how Panache queries, the contextual query, can scale much better as more parameters are coming in and so on. That's all I wanted to show you on the code side. Let me show you a little bit how you would make that application run in a native way. So for people that have tried to use GraalVM and compile your application natively, first of all, you've seen that it fails because there is a lot of constraints. But Quarkus actually handles all of that for you and also simplified the way to do the compilation. So you just say, I want to package, but I want to compile stuff also in the native compilation, not just Java jars. And it takes a while because it does a lot of complex analysis to compile your Java application, not at runtime, but at build time. So I'll put a notification here. And in the meantime, let me actually go back to the Quarkus website. There is guides that are very oriented into how do I need to do this stuff concretely. And we've got a ton of those, whether they are about configuration, logging, SSL, web stuff, data stuff, messaging, security, cloud, observability, and so on and so on. The one I want to dive into is the Hibernate ORM with Panache. So as we've seen, you don't have to set up a persistence.xml. We can infer it from the shared Quarkus application.properties file. And you can use the active record way to write an entity by extending Panache entity. We do recommend you use public fields because it makes the code a bit more compact and easier to read. And you essentially have your repository methods on the entity itself. Here you've seen the configuration. All of those are mandatory. The other one is optional. You can write the getters and the setters and do something with them, and then Quarkus again will rewire the call to .name to .getName inside your application. So you get the abstraction without having any problem here. We've seen that because it's an active record pattern, you've got operations on the entity itself, like persist, is persistent, delete, list all, find by ID, list which accepts a query, which is a contextualized HQL query, so it can be very compact, so it's very nice. You can do counts or count with a query, and so on and so on. So I'll let you go there. You can retrieve the list. You can do streaming to play with the collections, the stream, the Java streams. You can do pagination, so you define the page size, you define which page specifically you want, you can move to the next page. And of course, when you do list, you will only get those 25 results. That makes sense. Also, you've got the page count, which means you just say ask for page count, and we do the query, give you back the list of the number of pages expected, right? So it's very easy to make those kind of classical search engine. Sorting, we've seen. So either you put it in the query itself or you externalize it. So it depends on your taste here. Simplified query, I don't like for them to be called simplified because you can make very complex query. They're just contextualized. So the from entity is optional, the where is optional, the order by is optional, and we focus on the predicates. But then you can write the from if you want to do a from with a join or anything like that. It's you just pass this more complex line to the list operation. You can have parameters. I've shown a little bit how it works. The one thing I wanted to mention is some people don't like to merge the entity code and the repository code. They like to keep it separated. You can, no problem. You just create your class, you make it implement the Panache repository, and then you put the same method that I was mentioning. And of course, you've got the find by ID and all of those operations that you had on the active record entity. The only additional step you have to do is to inject the repository in your code and then call the repository to do your operations, which means from a coding point of view, I don't know if you've seen, but I've been really moving, stayed within the same code, the same methods and so on, not having to go back up in my code and back down. So that's the kind of thing we're trying to limit. I won't spend more of your time. Just a conclusion, you've got a full stack, including JPA transaction manager. It starts really fast with the live reload, and you can edit your stuff in the database with the live reload, which is really great. And we try to simplify this. The simple stuff should really, the common stuff should really be made simple, and that's what we've been working on, as long as the very short code to test loop. That's all I wanted to say to you today. I hope there is a couple of questions, then we can have a conversation.
We do have a couple questions, Emmanuel. One that I think is actually important, and that is related to Panache and relationships, one to many, many to one. How would you handle those in a Panache-based application?
It would just work. So Panache is actually a layer on top of JPA and Hibernate. So everything that you're used to working in Hibernate is just works. So many to many, one to many, all of that is orthogonal to the whole Panache aspect. If your query becomes complex and involves relations, that's what I was mentioning, where in the list, instead of just passing the predicate, you will pass probably a more complex from clause with joins and then the where clause associated to it. So, but just the way you use it in Hibernate. So it makes it easy for the simple case, but doable for the complex case. That's the logic we were trying to run with for Panache.
Okay, and then just kind of a reiteration of a point. Do I need to use a persistence XML with Panache, or can I? Should I? What is the strategy there?
You can. So if you're very much into keeping your application standard, go for it. But if you don't have to do this extra ceremony. Just define your data source in Quarkus and off you go. So that's the recommended way to get started. And if your application becomes too complex and needs a separated persistence.xml for complex settings, whatever, then you can go and use it. Again, opinionated and very simple, but doable for the more complex case.
Okay. One last question, and then we do need to kind of wrap up here soon, and that is related to migration. So a lot of people, that's a common question is, hey, what does it take to migrate an existing application over to this new world? What strategies do you have and recommendations for people?
So what we've seen is, so first of all, we use a lot of existing frameworks and standards. So if your application was using CDI and Hibernate and JAX-RS and so on, we've seen quite a few people actually taking their applications, spending half a day on it, and making it run on Quarkus, and be like really impressed by the ease of use on that front. If you are, what was the second part of your question? I'm lost.
Well, just overall strategies for migrating from an existing code base into Quarkus. That's all.
Yeah. Okay. So to be fair, it's really for, greenfield application would be the easiest way to get started. If you feel like your application is already somewhat in the microservices front and you want to port this stuff in a limited amount of time, that the fact that we've reused all of those existing libraries, and we don't even new APIs or new annotations. We just expose the one and we make them run much faster from a build startup time point of view and the amount of memory you use. That's all.
Yeah.
So yeah, it's not magic, but it's getting closer.
But I really do love the point you made. We have seen a number of people out in the social media world, right? Basically have told us they were able to migrate an existing microservice right over, leverage the Quarkus capabilities to go native, to get faster, smaller, faster, and of course, native compilation, which was so cool. But we are out of time for today. A couple other comments there. Edson Yanaga saying, I recommend Flyway for database migration. So he's trying to make that point there.
You have an extension for it.
Yeah, so maybe next time you got to add that to the demo.
Yeah.
And I love the Hibernate search. I love the Hibernate search reference, by the way. I thought that was cool. That was super cool. I haven't seen that one yet. Well, thank you all for your time today. We do need to get out of here because we do have a 30-minute time limit. Emmanuel, awesome job on that demonstration. Several people did catch the typo with the list dash extensions. So it was close.
Oh, yeah.
Yeah, no worries though. It all worked out great. Yeah, exactly. So you guys know it was live today. Look for the recording and an email that comes out from our marketing team. If not, do go to our standard channel on YouTube and you'll see all the recordings there as well. You can also go to the playlist I run on my channel. So you will have access to recording as soon as possible. But again, thank you all for your time. Thank you, Emmanuel.
You're welcome. And goodbye, everyone.